we're asked to use division on the interval 1 to 2. Let me write that down for you. So on the interval 1 to 2, we're asked to divide this into 3 equal parts. Okay, and using that information, find the area, the signed area from 1 to 2 of the function 1 over x with respect to x, so dx. I shouldn't say with respect to x, but using that variable, so meaning the x-axis. And we need this error, and we need to estimate this guy within 1/10. So what we're going to do is we're going to get lower and upper estimates for this. So what I'm going to do is I'm going to graph out my curve is 1 over x. So we know that that guy looks something like this. Here's 1. Here's 2. What I'm going to do here is take this region. Okay, I need to find this area in here, and so I'm going to divide it into 3 equal parts. Just like that. So this guy becomes 1 1/3, and this guy becomes 1 2/3. Okay, or 1.3 repeating, 1.6 repeating. So I've got my intervals. Now my lower estimate. Let's do the lower one in green here. The lower estimate would be one possibility for a lower estimate is to take these 3 guys right here. So let's call this guy x0. Let's call this guy in between. Let me erase all this. This is a lot here. Let's call this guy x1. Let's call this guy x2. And of course that guy's x3. Well, what we want to do, so I'm going to write it out using all the notation so that you get used to this here. Okay, so what we've got is we want to sum for the lower one. We want to sum from I equals 1 to 3. Now for the lower one, we want to be using the right hand pieces here. So I want to be using x1, x2, x3. So what we want is the function at xi times delta xi. Now these guys are all going to be the same. So delta xi, each delta x is going to be the total length, which is 1, divided by how many times we subdivide it, which we know that is 3. Okay? So this means that each delta xi is equal to a third. Well, that makes sense. Each of these bases is a third. So we want to sum from I equals 1 to 3 f of xi times 1/3. So let's pull that 1/3 out. I equals 1 to 3 of f of xi. Well, what are each of these xi's? Well, the first one is over here at 1 1/3. So this is going to be 1/3 times 1 over 1 1/3, which is 4/3. Just like that. Okay. Now the next one is going to be 1/3 for its base length, and then 1 over. Now this is going to be 1 2/3. So that's 5/3. And then the next one is going to be 1/3 over, or excuse me, 1/3 of a length, and then its height value is going to be 1 over 2, just like that. So this is 1/3 times 3/4 plus 1/3 times 3/5 plus 1/3 times 2 over 1. So this should be 6/12 plus 3/15 plus 2/3. And so that'll be a half plus a fifth plus 2/3. So let's get these guys all under the same thing. So probably the best thing to use here. Hang on 1 second. So I think I can get a common denominator here of 30, which seems not quite right. So let's see here. 3/4, 3/5, 1/2. Yeah. Okay. Hang on 1 second. Something just doesn't seem quite right. Ah, I found it. This guy right here should only be 3/12, so that gives us 1/4. That looks better. Okay, so now my common denominator looks like it's 60, because these are all, well, this isn't prime, but they're all what we call relatively prime, okay? So over 60, which means that I'm going to have 15 over 60 plus 12 over 60 plus 20/40, it looks like, over 60. So I think, let's see here. Let me just work that guy one more time. Over 60. Let's see here. To get this over 60, multiply top and bottom. Let me rework this. So 3 over 12. This should be 1 over 5. This should be 2 over 3. Okay, just like that. Where did I get these numbers from? Oh, I saw another error here. This guy right here should be 1 divided by, I still the value 2. Hang on. Yeah, I don't know why I flipped it right here. I shouldn't have. I think because I was flipping the other ones, I just got in the habit of that. So this is over 6. So this is still 1/6. That looks better. Okay. So now we've got 30 over 60. Okay, plus 20. Man, why are my numbers not working out here? Now the numbers are working out. I'm just been doing these for a while. So okay, if I've got 1/4 and I want to get a common denominator of 60, that means I've got to multiply top and bottom here by, I believe, 15. And then here over 60 it's going to be 12. And here this will be 10. And there we go. That gives me my 37 over 60. So that's my lower estimate. Now let's go ahead and take a look at the upper estimate. Okay, so let's take these guys instead here. Whoops. Like that. Okay, so I'll work this one in blue. So that's going to be, I need to add. Now, since I'm going to be using the left-hand sides of these guys, oops, let's go up to 3. Okay. So I'm going to be using the left-hand sides of these. I need these at f of xi minus 1 times delta xi. So it's the difference here. So what this gives me, this guy is still a third. I need the sums I equals 1 to 3 of f at xi minus 1, which basically means I need to take these left endpoints. So this says I need to take 1/3 times f at x0 plus f at x1 plus f at x2, and then we're done. So this will be 1/3. F at x0, the height at x0 is 1 over 1, so that's just 1. At x1, okay, that's 1 1/3 over, so it's 1 over 4/3, which is 3/4. And then this one will give me 1 over 5/3, which is 3/5. So when I multiply the 1/3 in there, I get 1/3 plus 1/4 plus 1/5. And a third plus a fourth plus a fifth, it looks like we can still do 60 as our denominator there. So that would be 20 over 60 plus 15 over 60 plus 12 over 60. And that'll give me, I believe, 47 over 60. Now what you notice is my lower estimate here was 37 over 60. My upper estimate was 47 over 60. That means that the integral, the actual area, okay, between 1 and 2 of f of x dx has to be between those upper and lower bounds. So it's going to be between 47 over 60 and 37 over 60, which means that we're within 1/10.